Hey there, I hope you're ready to do some more economics because you are back with microeconomics with me, Professor Dan. Today, what we're going to be looking at in our unit here on efficiency and market interventions is we're going to start thinking about taxes and subsidies. We'll look at how they change prices, how they change quantities, and the impact on the distribution and the size of our economic surplus. So these are going to be a little bit more complicated. And the way I think about it is without a tax or a subsidy, the transacted price, it's both the take-home amount for producers, what they are kind of getting, and it's the out-of-pocket cost for consumers, the total amount they're paying. And both of these are transacted price, the price that's transferred directly from consumers to producers. Taxes and subsidies change this. With a tax, there's a difference. We're going to have a difference between the out-of-pocket cost for consumers, the take-home amount for producers, and the transacted price. So for consumers, their out-of-pocket cost is going to be the transacted price. It's also if they are having to pay any tax, we're going to add that in. If they're getting any subsidy paid by the government to them, we can take that out. For producers, their take-home amount, it's going to be the transacted price, what they're getting from the consumer. If they have to pay the government any taxes, we're going to take that out. And if the government is giving them a subsidy, we're going to add that in. You'll notice that a tax is positive for the consumer and negative for the producer. That's just because we're considering this a cost. And so cost is increasing, and we're considering this a benefit, so benefit is decreasing. Furthermore, taxes and subsidies, they're paid by or given to either the consumer or the producer, generally not both. And in this work, to keep things simple, we'll only be using and looking at one of the four options at a time, either a tax or a subsidy, either on the consumer or on the producer. Now, the key to understanding this material, the key to getting your head around what's happening, to making sure that you're getting this right, is recognizing the answer to this question. Does a tax change anything about the response between quantity supplied and the take-home amount? In other words, for producers, is anything changing in terms of how much they're willing to make versus how much they're taking home, right? This is the supply curve generally. And the answer is no. Nothing's really changing for producers in that way. What's changing is the relationship between the transacted price and take-home amount. I'll drive that home again, but the same thing's true about consumers. The consumers, they care about how much they're ultimately paying, their out-of-pocket cost. They don't care whether that money is going to the government or that money is going to the producer. It's the same to them. It's out-of-pocket cost, and the relationship between how much they want to buy and out-of-pocket cost is not changing. All right, so now that we know the key to understanding, let's look at an example of a tax paid by the producers. So the producers, their take-home amount is going to be the transacted price, the amount they're getting from consumers, and then they're going to have to pay the tax, so minus the tax. For consumers, their out-of-pocket amount is just the transacted price. Now that we understand those relationships, let's look at the supply and demand curves. We'll start with the demand curve because it's going to be simple because they don't have a tax. The demand curve is going to be the out-of-pocket cost equals that transacted price. And what we have here these are just some placeholder coefficients that are numbers that describe a linear demand curve. This doesn't change, right? Nothing has changed in terms of our demand curve. For our supply curve, This is the unchanging relationship that our take-home amount equals this. These are just some placeholder coefficients. These are numbers that describe a linear supply curve. This is not going to change. What is changing is this, right? The fact that our take-home amount is no longer transacted price. It's transacted price minus tax. So here we have this, which our take-home amount is the transacted price minus tax equals this linear supply curve. Now, when we graph our supply curve, we want to also be able to show the relationship between transacted price and quantity supplied. So we simply add the tax to both sides. And again, what we're seeing here is our graph supply curve. What's happening here is that the relationship between quantity supplied and transacted price is shifting up by the tax. Let's look at this graphically. Here's our supply and demand market without a tax. For demand, the transacted amount is the out-of-pocket amount. For the supplier, before we have a tax, the transacted amount is the take-home amount. When we institute a tax, the supply curve shifts up by t because now we have a difference between the transacted amount and the take-home amount. This take-home curves never moves unless something that shifts the supply curve moves, like production cost. For the consumers, the out-of-pocket demand curve will not move unless something like taste and preference changes, but not taxes or subsidies. These are our simple taxes that are per unit taxes. It's a little more complicated if it's a percentage tax. That depends on price. So these are just per unit taxes. That's why it's a parallel shift. So we have this shift up by t. Now the question becomes, what happens to transacted price? Right? It used to be at P2. Does it just go up by t from P2 to P4? In other words, do consumers pay everything? Is their price just going up and producers get the same take-home amount? That's what would price of P4 would mean. Or do consumers pay the same amount, this P2 that was originally paid, and producers just take the hit? Now, to be clear, a transacted price of P2 would have a take-home price down here. So this is going to depend, we'll show later, on the elasticities of supply and demand, but usually it's going to be something in the middle. Graphically, the price is going to be where the supply for the transacted price intersects the demand for the transacted price. That transaction moving from consumers to producers is the thing we need to match up. So we're looking for that intersection. That's going to give us the quantity and the transacted price, and then the take-home price is going to be lower. It's going to be down here. Note, when we have this tax, the transacted quantity is also decreasing. Now let's take a closer look at that using our framework of consumer and producer surplus. So you can see in this table here, I've now added a row to capture the revenue the government is taking in. So when we don't have a tax, the transacted price, the out-of-pocket cost, the take-home amount, all of those are the same thing. This price 2 captures everything there. With a tax, right, we have this split between the transacted amount and the take-home amount. Those are going to be different amounts because of that tax on the producers. The transacted price, that's going to be P1, the intersection of our transacted curves. The out-of-pocket is going to be P1 as well. There's been no change in our demand curve. The transacted demand curve is the out-of-pocket demand curve. The take-home amount for the supplier, for the producer, is going to be P1 minus the tax, which is P3 down here, and that quantity is going to be Q1. Everyone agrees, quantity demanded, quantity supplied, it's Q1. So let's look now at our surpluses. For the consumer, it's fairly straightforward. This price, transacted and out of pocket, difference between that and their out of pocket, what they're paying. For the producer, what do we look at? I think the clearest way to think this through is to stick to the take-home amounts. Look at our take-home supply curve and compare it to our take-home amount. The take-home amount is P3, and the distance between those two, the area between those two is D. Now, because this is a parallel shift, this triangle, which is not labeled, that is bound by the transacted price and the transacted supply, will have the same area. I think it is easier and a little bit clearer to just stick to the take-home and the take-home. All right, now we have this new part, tax revenue. What is our tax revenue going to be? Well, we have one kind of tax, it's a per unit tax. So to find our revenue, we simply multiply our tax by that quantity. So our quantity is Q1, our tax here, T, is the difference between P1 and P3. And so we have the areas B and C as tax revenue. So if we add all of these up, we have A, B, C, and D as our total surpluses. Do we have a deadweight loss? Well, back in the day, we used to have E and F. That's our deadweight loss. Society is losing out on surplus because of the tax. Now let's look at a tax paid for by consumers. Again, remember the key to understanding, the underlying relationship does not change. So we've got producers, we've got consumers, now the tax is on consumers. This is a positive, they have to pay more. The supply curve does not change because the take-home amount is the transacted price. There's no change on that side. For the demand curve, we now have our unchanging relationship here. The out-of-pocket equals these coefficients and the quantity demanded. But out-of-pocket is no longer a transacted price. They're no longer the same thing. We have this tax thrown in here. So to describe the relationship between transacted price and the quantity demanded, we subtract both sides by T. This is meaning that the relationship between transacted price and quantity demanded shifts down by the tax. All right, let's return to our graphical example. Here is the market with no taxes that we've seen a couple of times now. Again, the take-home price, the out-of-pocket price, and the transacted price, all of those are the same in this market. The tax changes that. So now the supply is unchanged. The take-home equals the transacted, but the demand is split. We have our out-of-pocket demand curve, which does not move, and then we have our transacted demand curve, which has shifted down by the tax. As we saw before, and as you hopefully remember, the equilibrium or transacted quantity here is going to be the intersection of your transacted supply curve and your transacted demand curve. That's P3 at a quantity of Q1. The out-of-pocket amount, well, you're paying P3, but you're also paying the tax. So you move up by the tax, that's P1. The take-home amount for the supplier is the transacted amount, that's P3, and the quantity is Q1. So let's look at the surpluses here. The consumer surplus is, again, we look at the out-of-pocket, is what we want to stick to. We could do transacted to transacted, but I think it's sounder to do to stick to the out-of-pocket. You're less likely to make mistakes. The producer, the transacted is the take-home, so the area below P3 above the supply curve. And don't forget our tax revenue. Again, it's the tax amount per unit times the number of units of this area with the height of tax and a width of the quantity. So again, looking at the total, we add them together, A, B, C, and D, and then we think about, well, what have we lost compared to that completely free market? We have lost E and F. That is our deadweight loss. So a note on our deadweight loss, now that we have looked at all these different restrictions, we've looked at the ceiling, we've looked at the floor, we've looked at the quota, we've looked at a tax on producers and consumers. Each restriction had the same deadweight loss. It had this area E and F. Now, the reason that was because each restriction resulted in an identical decrease in transactions. We used to have this Q2, now we have Q1. These transactions are no longer happening. Now, these transactions we call mutually beneficial transactions, meaning the consumer's willingness to pay, this demand curve, is above the producer's cost of production, the supply curve. That's where the deadweight loss is coming from. These types of restrictions, the type of restriction is determining exactly which group is losing what or benefiting, consumers, producers, or government, splitting B and C. But each of them resulted in these transactions not happening, which is why they all had the loss of E and F. The final thing that I want to show you and look at is the market with a subsidy. This is going to be a little bit more messy in terms of our graph, and it's not going to have the exact same loss structure as we do here. It's going to be a little bit harder to show. We're going to have some overlapping areas here. So here is our start. Note I've changed the prices a little bit in terms of where they intersect. We have slightly different areas in terms of what E and F mean. But where we start is, again, price 2 being the transacted price, the out-of-pocket price, and the take-home price. Now we're going to put a subsidy for producers. If you remember, the tax shifted it up, the subsidy shifts it down because you are getting that transacted amount plus the subsidy gives you your take-home amount. Now, to find the transacted price, we look for that intersection of the transacted supply and transacted demand, that's P3. To find the out-of-pocket cost for the consumer, we look at the out-of-pocket demand. That's the same as transacted demand. Nothing has changed for the consumers. The take-home amount, well, they're going to take home even more, right? More than P3. P3 plus the subsidy is that P1. And the transacted quantity is that intersection between the transacted curves. That's at Q3. Let's look at this surplus. The consumer used to have A and B. Now they added C and F. So they like the subsidy. The producer, they used to have D and C. They now have D, C, B, and F. They like the subsidy. So it seems like it might be mutually beneficial. Both of them have higher surplus. So we have to think about what the cost for that subsidy was. It wasn't free, it's the government paying out money. So the subsidy cost, because it's a per unit subsidy, is the number of units times the quantity. Sorry, times the subsidy. The number of units, Q3, times the subsidy. And we can see that graphically that is the area of B, C, E, F, and G. And so if we look at our total surplus, if we add consumer surplus plus producer surplus minus the subsidy cost, we see that C and F, B and E get canceled out from the subsidies cost. And so our total here is, well, we still have A, B, D, and C, but we have this minus G, right? This G was subsidy cost that was not going to anybody. In fact, where this cost ends up is in deadweight loss. Now, before we said that the deadweight loss was happening because mutually beneficial transactions were not occurring. Well, what we have here are transactions that are occurring where this cost without the subsidy is greater than the benefit without the subsidy. So these are the opposite of mutually beneficial. These are where the cost is greater, and that's where the loss is coming from. So we said that let's think about the size of the deadweight loss. It is actually going to be quite related to the elasticities. Let's look at it in terms of the elasticity of demand. So on the left, we have the original. On the right, the original demand is in this light blue. We're going to have less elastic demand, right? Less elastic demand means that for a given change in quantity, you need a bigger change in price, or for the same change in price, there's a smaller change in quantity. Graphically, it's shown as something steeper. So if we have less elastic demand, which we have here, we have the same change, the same tax. This means we're going to have a smaller change in quantity. This change here is smaller than this change here. A change in quantity B is smaller than the change in quantity A. Because we have the same tax and the deadweight loss is 1/2 the tax times the change in quantity, we're going to have a smaller deadweight loss. So smaller elasticities of demand, smaller deadweight loss. Let's now think about elasticity of supply. Is the same thing true? So here's our original supply. Now let's make one more less elastic. And then we see with this less elastic supply, we have less of a change in quantity, a smaller response. This smaller response, because the deadweight loss is 1/2 the tax, which stays the same, times the change in quantity, it's a smaller deadweight loss. So, as is always the case, deadweight loss is stemming from changes in quantity because it's stemming from changes in transactions that aren't occurring. When we have more price elastic, there's a bigger change in quantity and a bigger deadweight loss. There's a mathematical formula that represents this. I'm going to give it to you. I'm not going to expect you to memorize it, but it's a really nice formula, and this is using the negative version of elasticity of demand, and it shows the relationship between the deadweight loss and the elasticities, factoring in quantity and price. This means that it's more economically efficient in terms of deadweight loss to tax inelastic goods, things that aren't going to have a big change. Because when you tax inelastic goods, you're changing the distribution of the surplus, maybe moving some money to the government from other people, but you're not changing what transactions happen. And that's fundamentally what efficiency is about. Are the right transactions happening? So that ends our analysis of taxes and subsidies in terms of how these surpluses are changed. What we're going to talk about next is what's known as incidence. Just because you're paying the money to the government doesn't mean that you are the one burdened by the tax. And so we'll get into that and talk about how the tax burden is shared and how the subsidy is spread between producers and consumers. Take care.